Okay, so this is part 3 of the computer mouse fix. We have identified that one of the switches has a problem, and we're going to be working on addressing that. So I have never disassembled this mouse before. We're going to be removing the switch from the right side and resoldering it to the left side and swapping it. Swapping this switch with this switch. Alright, so over here, as I mentioned before, this is a Razer mouse. I purchased it for like $150, and it's a good mouse. I like it. I don't want to buy a new one. Alright, so you might want to start, if you have the same problem, if you decide to go through the same route of fixing it as I do, you would remove the strips here. You can just pick at it with your finger to get it removed, kind of like this. There's basically going to need to apply glue to put it back together. But there's basically 3 screws from what I see. They are the star-shaped type of socket. If you can see this here, kind of like this. So put it here. This is too big. This one is too big as well. Find the right one. Well, this one is too small. No, this is the right size. Okay, let's see what this expensive mouse is made from. Yeah, I wish Razer would be upfront and honest with people, with their consumers, and tell them, hey, you know what? We have a switch in that mouse that after 5 or so years of active use, it's going to break on you. So you might want to just get a new mouse. Instead of, there's so many videos online, people trying to get different programs, and they think that it's a driver problem, something with their hardware, sorry, software, when in reality it's a hardware issue. Alright, so let's see what happens next. How to disassemble this thing. Okay, we're going to remove. I'm going to use a flat and screwdriver here to pry it open. There's probably some kind of clips or something somewhere holding this in place. Oop, there we go. Ooh, it's more complex than I thought. You definitely don't want to have any static on you, so I would touch something that's grounded from time to time when you're working with this, because static can damage electronics. Right, so first thing that I'll do is I'm going to pop this off. It's kind of difficult to work with. Camera in front of me, but I'll try to. I just pulled it out. Looks like it slides pretty easily. I wonder what this whole thing is. What is this? Oh, it's a switch. Yeah. Alright, so it's a basic standard switch right over here that has stopped working properly. So I'm just looking at this thing. is there any difference in the movement of the plastic components? Looks like it's pretty much the same. I'm just looking to see if there's any additional things that I need to consider. There's something that may be dropped, or yeah, I do want to make sure that we're still having the problem, and I can replicate the problem with the mouse disassembled. So what we'll do is we're going to reconnect it. I might want to use tweezers or something. And we're going to reconnect it and connect it to the computer in a disassembled mode. Okay, just like this. There we go. And we're just going to go and test the mouse out. Alright, so like this. Going to go to that website, mouse test. I'm trying to use my computer right now. Let me see if I can show you what I'm doing. It's not this one. Yeah, I can actually see the double clicks here. As I'm pressing the mouse, this thing is just giving me trouble. I think this is this one. Yeah. So if I click, it's going to show me how many clicks I made. I'm just triggering that by myself. So technically, if I press and wiggle it around, it should generate like double clicks, which I'm not seeing it do that. The switch seems to be working properly. Oh, it double clicked or something there. Yeah, it definitely skips and creates double clicks from time to time, from what I see. 536. Yeah, there we go. See, there is a position just before I release it. That's when it's creating a whole bunch of clicks. Alright, so what about this switch on the right hand side? Does it have that problem? Just before I release it. No, it doesn't. Right, so yeah, definitely we know that there's a problem with the switch. So we're going to unsolder this one and resolder it here, and then basically we'll swap those two around. That's what we'll do. So now we have proved what the problem is. You always want to double check, triple check, quadruple check everything that you're doing, because you might think that you know what the problem is, but you will soon discover that you actually don't know what the problem is. It happened to me frequently. Happens to everybody. Whoever worked in electronic engineering and tech field. All of us know this. So I have removed this battery so that we're de-energizing the circuit completely. And now I'm looking for screws that hold the PCB board. So this is okay. So we have a screw right over here. So there's actually two of them, and I need to find the right bit size. I think this is it. Yep. So removing, unscrewing to take out the PCB board. Make sure you have a jar or something to put the screws, so don't lose them. Don't just toss them on the table like I'm doing. That's not a good habit. Yeah, there's more screws. See, there's a standoff over here, and there's a tiny screw right under the battery. There's probably some more screws right under the battery. So the battery is preventing us from getting at those screws. We'll need to remove the battery. Don't just yank the battery by the leads. You're going to break it. The battery is probably, it's a lithium battery. It's a very large battery for such a small mouse, because that's how they get such a large amount of time that it can operate on a single charge. That's why they have a huge battery pack here. So I'm just going to carefully, slowly remove it. You want to use some kind of pry tool that's plastic. Don't use a screwdriver like I'm doing right now, especially a pointy screwdriver that I have right now. This is a really good way to damage the battery and poke a hole in it, get it overheated and explode and burn and get lithium all over the place. You know what, I'm going to get a different tool here. I once decided to replace a screen on my cell phone. I replaced it. It actually worked for a little, and then my cell phone got damaged because I didn't seal it correctly, and there was a lot of moisture that got inside, and ultimately had to buy a new phone. So maybe the same story will happen with this project here, I'm not sure, but we'll see. So this battery is really holding on really tight here. I wonder why it's not coming out. Like there's really something holding it. To use some crazy glue here. Ooh, I can hear the battery cracking. You know what? I think the battery is a goner now. I think I broke the battery. Good thing that it was de-energized. So if you're going to be doing this, I tell you what, don't do this. Most likely you will break the battery, because the glue that they used here is crazy. Well, it's not heating up. The battery is still cold. So hopefully it's still intact. I'm not sure. I just have to see. Huh? No, it's fine. It's not heating up. All right. Now we can see the screws. Let's take the tool and continue unscrewing stuff. We'll take this one out. We'll take this one out. Oops. We'll get this one out. All right. This piece can come off. Let's see if I can spot any more screws. Can you see any screws? Yes, I can see some screws. Here's a bunch of them. There's one here. See, good thing that we took out the battery. I wouldn't have been able to get to the screw if I didn't take out the battery. We'll take this one out. All right, any more screws? By the way, if you're going to take out the battery, maybe you might want to use some kind of alcohol, like rubbing alcohol. Sometimes it helps remove adhesives. Just a little bit of alcohol. Yeah, don't drink that alcohol. That's not going to help you. Use it to remove the adhesive. Alright, I'm going to remove this wheel. I'm going to unplug it. There we go. Hopefully I'm not going to break. There is a small clip over here, so you can use flat end of your screwdriver to just pry it open like this and take it out. There we go. This one was easy to remove. Let's see if we can spot some more screws here. There's a little bit of dust, nothing major, but I think we are. What are these buttons here? But you know what? What are these things? That's so weird. Why do we have buttons here? What's the point of those buttons? So if we connect this back, clip it back together, why is it not making a sound? Okay, the right one is making a sound. Left one, yes, it's making a sound. Yeah. It's crazy how much harder I have to push the left one. And what's the purpose of those small buttons here? What are these things for? Weird. Let's see. I'm going to connect the mouse. There we go. Connected it. This is like the craziest mouse ever. Look at it, it actually is still working. So I can use it. So I'm clicking on this thing and it's not triggering any clicks. So God knows what these buttons are for. I have no idea who invented them and for what purpose. Okay, it's weird. Hey, maybe those buttons are like a tax write-off. They had to make it more expensive. Who knows? I'm not seeing any more screws. There's like a switch here. And then there is this module over here. I think it should be able to come off. Oops. Okay, there we go. Just came out. Okay. 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 Looks like it's going to be an easy solder job now. Yeah, unsolder this 3 switches and replace them, swap them around. Solder and iron. Let's get to work. Okay, so this will be a little bit tricky because first of all, I don't have flux. I have not been soldering for a very long time. Unfortunately, I just don't have time. And this board is a multi-layer board. And all multi-layer boards have multiple grounds, multiple copper plates. One is ground, another one is power, that are running inside the thickness of it. Luckily, the board is not that thick, so it's not going to be too hard to worm it up through. And I don't have flux. I did find a piece of pine resin. Pine resin has been used before to solder things. Works kind of like flux. A lot worse though. But we've got to do what we've got to do. It's going to create a lot of really deliciously smelling aroma. So 3 pins are a little bit difficult to take out when they're spaced out this far apart. What's more difficult is that I don't have the right tools. I don't have the proper solder. I'm using solder to solder copper wires. Again, haven't been doing electronics for a very long time, so the way that I'll be doing is I'm going to be doing it the old-fashioned way. I'm going to be applying some pressure, burning my fingers. So I'm holding my finger here, I'm holding the switch, and I'm pressing with my thumb to have force going that way, and this finger is pressing this way so that we're pulling the switch out. And I'm also using a table as a leverage so that there's forces on all directions to take out the switch. And it's going to take a little bit of time to take it out. I can feel like micro movements of the switch, just like slowly making its way out of the board. Takes time. If I had a heat gun or a blowtorch, that would be much faster. But with blowtorch or heat gun, you're risking your other components because your other components can get overheated if you're not careful with them. And then it can ruin your processor or whatever other components you have on your board. There we go, can feel it moving. So we're just going back and forth. If you're on a budget like I am, just take your time with it, don't rush. It will come out eventually. Don't pull too hard. If you're going to pull too hard, you're going to melt the switch. And you don't want to just melt the switch. Now, here's the part where it gets a little bit difficult. Just before you were taking it out, the thing becomes really hot. And for some reason, solder is kind of difficult to melt at this stage. There we go, almost out. Notice how I'm not reaching, like I could have just went this way, but I'm not doing this because this will overheat the switch. It's going to melt the switch plastic, and then you're just going to lose the switch. You don't want to lose the switch. All right, so here we go. We have it out. It would be nice to have solder remover to remove excess solder from the pins, but we're on a budget. I don't have it. So let's just remove excess solder from the tip using a paper towel. You want to put it inside the resin, the flux, and then repeat the process with the switch number 2. So I'm just going to put this video on pause because it's insanely difficult to do this. By the way, when you're just starting out, it might feel like you're not really achieving anything. I know I have just removed solder and I'm putting solder back on. The solder is good because it creates thermal mass, and it also allows you to like hit 2 pins at the same time, which is really useful when you're trying to take out something that has multiple pins. Yeah, I'll put this video on pause. I'll take this thing out off camera because it's a lot easier than having a camera in my nose here. Just literally have to look over the camera to unsolder this. I am so happy I'm making this video because as soon as I took out the switches, I was like, oh boy, which one's which one was on which side. So this was on this side. I went back and looked through the video. So this is my defective switch, the bad switch. You can actually hear it. And this one's good switch. Yeah, this one is a lot firmer, and it really sounds loud. And this one sounds like it's broken. Can hardly. Yeah, there's definitely something's up with it. Yeah, this one sounds really good. So now we're going to repeat the process and solder them back on, swapping them around. So my left finger, this finger, left mouse, this one, will get a brand new switch. A switch that has not been used too often. And we're going to solder it back. I'm going to remove some solder, just like before. I'm going to remove solder, and then I'm going to clean up the holes. Again, it would be great to have a solder remover Just basically a piece of copper that you can use to clean up the solder, but I don't have it. Yeah, this is the new switch. Now I don't care which one's which. I can mix them around. I can actually find it just by listening to it. There's definitely a different sound to them. Okay. So how you solder the switch back on a budget? You clean up the solder the best you can. And then we're going to take our soldering iron. I know I told you not to do this before, but we are going to just slightly touch them here so that they will find their entry point into the 3 slots that we have. I'll try to do it on camera, but I cannot really look at the camera and see what you're seeing, because this is a very important part that I have to get done correctly. Otherwise it's going to make the rest of the operation very difficult. Alright, so again, micro movements, really small movements as this switch is slowly going to go into the holes. This is not the way to do it. The proper way is to remove all of the solder, make those holes empty. There are specific methods to desolder things. There are soldering irons that have forced air, so you press a button and that forces the air to fly and remove the solder for you. That's how it's done in the industry. Okay, we're going to try a different method, solder bridge. So we're going to bridge all of them together so that all of it is melted at the same time. Wiggle it around. Ooh, it's hot. I can feel how the heat is getting transferred through the copper plates inside. See, the switch came off. It wasn't aligned properly. Alright, I think I'll have to try a different method. I do have to clean it up. So we're going to do a smack method. We're going to heat up a hole really well. Then I'm going to smack it against the table. And it's going to basically move that solder out of that hole. You might have to do it a couple of times. Heat it up really well, smash it against the table. See, now we have a hole. Okay, so I think this is the best way. Heat it up, smash it against the table. Heat it up, smash it against the table. There you go. Hopefully you're learning something interesting. Okay, this is not, I'm not telling you that this is the right way of doing things. This is for educational. No, this is not educational. This is entertainment. Yep. Entertainment purpose only. So this last one over here is connected to the ground plate. This is probably ground. That's why it's so difficult to take the solder out of this one, which is fine. We have 2 holes that are completely empty. We want to make sure that we're taking our good switch, which is our left hand side switch, and we're going to move it right over here clean up the solder. I'm just going to do this smash method with the switch again as well, so that we're cleaning out excess solder as clean as possible. Okay, and this one as well. If you have flux, use it. Okay, I know I will be able to push it into the first two holes. Now the third one is a ground plate that dissipates heat like crazy, so I will have to use some solder. Now make sure the switch is all the way down, because the computer mouse has very specific heights. Like everything has to be really perfect for it to work properly. Okay, so there we go. It's in. So we're going to solder it now. We'll solder it back together. So I'm going to use just a little bit of flux on here, or more specifically pine resin, so that we have a good solid solder connection. This is lead-free, flux-free solder. Horrible stuff to work with. Okay. What I'm looking for is nice, glossy, kind of beautiful look to the solder joint. This one is not. This looks like a cold solder joint. So to heat it up a little bit more. There we go. Okay, this is nice. Beautiful. Beautiful. Okay, this is perfect. Okay, awesome. Now we're going to repeat the same process on this side. Going to heat it up, knock the excess solder out. See, nothing came out because I didn't heat it hard enough. Just keep it a little bit longer. This might be the ground plate for this one, or maybe connected to one of the power plates. I'm not sure. I might actually have to use a little bit more solder. I think there's not enough solder to create enough of mass to fly out. Sometimes you have to add more solder for this method to work. There we go, see, that did the trick. A lot of things in electronics are counterintuitive. By the way, if you have a computer mouse that you want me to trial, to take apart and see what's inside of it, feel free to send it over. We can make a YouTube video about it. We can take it apart, look at the components, make a nice YouTube video out of it. I have a bachelor's in electronic engineering. I worked as an electronic engineer for 5 years. So I do have quite a bit of expertise in the field. Alright, so we're going to, this time I think I was able to remove all of the, no, one hole still not removed. The solder is still there. So I'm just going to melt it and put it in, just like that. So this is our defective switch. Technically you could buy a new switch. This is just a standard switch. Nothing special. They make them in China a lot. You can buy a switch like this for like $1 on DigiKey, maybe less than that. Then you have a fully fixed mouse without any problems. This one is giving me some trouble. There we go. There we go, finally it went in. It's fully in now. Oh, my fingers are burning. Alright, finally. Let's put some flux on here and get this finished up. Before we are going to assemble it, we're going to test it to make sure that everything is working. And if it's not working, I'm just going to buy myself a new mouse. I don't typically do this, but this mouse is expensive. And you know what? It's almost New Year's. I don't want to spend money on buying stuff because I need to save up right now. We have a major project that we're working on. Alrighty, so to test this, we're going to just quickly but carefully look at this to make sure that there's no problems. Yeah, looks good. We're going to place this back here. I still have no idea why they have the additional switches over here. Alright, it's in. Now we're going to connect it to a computer. I like the assembly quality. If they have used higher quality switch, I'm sure this mouse would be really nice. Okay, it's still working, which is great. Let's see if the clicks are counting. Yeah, the clicks are counting properly. Yeah, the the right hand switch is absolutely disgusting. It's not even clicking anymore. I can see that it's registering some kind of click, but it's absolutely horrible. But I don't care. This will be good for now. I don't use the right clicks much anyways. I'm no gamer. I don't do computer games at all. So mostly do web development. I have a company that builds websites. I know it. I see now I have switches here. See, this wheel is connected to those switches. That's why we have it. Did you see that? Let me know if you actually seen that. Now I have to position this so that it actually goes there and doesn't break it. Then we also need to put this small wheel in here, and looks like it's in, yeah, right, left. That's what, let's see, so we can move it to the right, move it to the left, and that's what's pressing those switches, right? Okay, so this will go over here. This is our scroll wheel. It's in. And now we need to screw the whole thing back together. So basically the same assembly process as we have disassembled it. The same process, but in the reverse order. We're going to be assembling it together now. So just a bunch of different screws. I really like that they have specific screws for specific things, like this screws that have a flat head. They are specifically for motherboard, for this PCB. And then the ones that are a little bit larger, they're for the standoff. Oops, the screw. Did you know that a computer mouse is actually a very complicated piece of electronic device? Like, it's really complicated the way that it works. Inside the computer mouse there is a very powerful processor. It's not just basic processor that looks, did you move your hand to the right or to the left? In order for it to actually have that information, where the heck did you move your hand to, where the mouse moved, it actually takes pictures. Yeah, believe it or not, it takes pictures. It takes pictures of a tiny spot on your table using a tiny camera over here, and then it compares one picture with the next picture, with the next picture, with the next picture, and then by comparing the two different pictures and finding specific points on those pictures, it's able to decipher how far one picture transitioned to the next and creates new coordinates of the movement. So for it to be able to compare one picture with the next, it has to have a very specific processor. That specific processor is called digital signal processor. DSC for short. Digital signal processing capability that allows it to process digital data and analyze images. Okay, so looks like the rest of the screws are exactly the same. So this will be the next piece that will come right over here, like this. So digital signal processing is a complex process. It requires a lot of work, a lot of studies to be able to know how to work with digital signal processing. Actually, I'll take my word back. The screws with the star belong to the outside, and the screws with a cross or an X belong to here. I'm actually really happy with the quality of this computer mouse. It's nice, solid. If it wasn't for the switch, we wouldn't know how it's built. So I guess it's a blessing in disguise. Now we know how the computer mouse is built. Maybe this video will help people figure out. You know what? I think this battery is still good. I'm pretty sure it's still good. We're just going to use it. Pop it back in place. Okay, got to be careful. Make sure you're connecting it correctly. Alright, so the battery is in place. I'm going to keep using the same adhesive. I'm pretty sure over time it's going to reseal itself. And then we're going to take the small connector, connect it back to where it came from. Go on. It's a little bit, gives me a little bit of a trouble here. There we go. And we're going to assemble it back together again. Okay, before we're going to finish it off, I'm going to feel and test it. Is it working the way that it should be working? Can I actually work with this mouse? Okay, so the left hand switch is difficult to press. It's not glitching, but it's difficult to press. Why is it so difficult to press, I wonder? Is it because I haven't screwed it in yet? Or is there a different problem with it? Oh, now it's fine. Yeah, it just needed to click in place. Okay, so the right hand switch is completely shot. I cannot even hear a click now. And it just takes a gentle tap for it to actually trigger the right hand switch. I don't like that. I do not like that. I'm going to need to modify the right hand switch so that it doesn't do that. So I'll take my pry tool, going to pry it open. I've seen something on the right hand switch, which I think I know what's causing that issue. Where the heck are those clips? Okay, so the right hand switch. It takes no effort at all to press this button. We should reduce the height here somehow. Okay, I think I've depressed something in here. It would be nice to take a Dremel to it and just shave this off a little bit. But you know what, maybe I should just get a new switch, disassemble it again, and rebuild it. That's what I'll do. I'll just buy myself a new switch and I'll redo it. So for now, I'll just have to work with what I have. It works fine, with the exception of the right hand mouse click. Now that my left switch is working so well, I want to get the right one to function just as well. Once I'm going to fix the right switch, I'll have a mouse that's going to work just like new. Right, so the last step here is to figure out where the heck did I put my receiver. I wonder where I lost it. But we're going to assemble it back together and call it a day. I think we have achieved our goal. Now we know exactly what the problem is with this computer mouse. The switch went bad, and more importantly, we know how to fix it. So if there's anybody out there that's telling you that the problem is with computer driver, or that Windows is no longer supporting something, it's not. It's the freaking switch. That's the core of the problem. That's why it's not working. There's no drivers or other problems with it. Specifically switch, which we can change, and it's going to work just as well as we have just proved it. You might want to apply some kind of glue here to put this back together so that it doesn't unstick. I'm not going to do it right now because I'm going to find that switch, and I'm going to disassemble it again and fix the right hand button so that I have a computer mouse that's as good as new, and hopefully it will work for another 10 or so years, or 5 years. I don't know how long I've used this computer mouse. Fairly lengthy time, and I work every day, so I don't want to just switch out the mouse to something else. Okay, this is good. Now clean up time, and we'll enjoy the use of our computer mouse. Yay! Okay, hopefully you found this video interesting. Yes, we went through the series of 3 videos. The first video was shot, and it had incorrect assumptions, but it helped point us in the direction of what would be the correct way to fix this problem. The second video, we have found what is the problem and created hypothesis, and on how to resolve the problem. And in the third video we have actually, this is the third video, we have actually fixed our computer mouse, Razer, and it's going to work as good as new. Alright, subscribe. I'm going to have a lot more interesting videos on this channel to address different problems in business and life in general.